first lecture on the topic limit. So what is a limit? Imagine you're leaving to a birthday party and your mom comes and tells you be home by 8 p.m. So that 8 p.m. in mathematics is called as a limit. Okay, let me take a function f of x. Imagine this is the party that you're going to. Okay, f of x, function party, yes. So as x is tending to 8, as the clock ticks 8, you should be home, right? Say that home is L. So what happens when you come home as the clock ticks 7:59? What happens if you come at 8:01 p.m.? What happens? That is what we are going to study in this chapter limits. Yes, we are going to study how the function works when the values approaches to the functions. Yes. So in general, let me give a general formula now. In general, as x tends to a, f of x tends to L, yes, where L is called as the limit of a function. And this is denoted by limit x tends to a, f of x is equal to L. Okay. Let me take an example now. Let me take f of x is equal to 3x. Okay. Give some values for x. Okay. Let us take that x is tending to 2. So let me take all the nearest values to 2. Okay. That is, yes, that is 1.9. Yes, 1.95. Yes, 1.99. Yes, 1.999. Okay, 2.01. 2.001. Yes, 2.01 and 2.1. So let me multiply now. X into, in the place of x, let me substitute 1.9, 1.95. Yes. So 1.9 into 3 is 5.7. Okay, 1.95 into 3 is 5.85. 1.99 into 3 is 5.97. Okay, 1.999 is 5.997. Okay, 3 into 2.001 is 6.003. I would get 6.03 and 6.3. Now, if I round off these values, yes, I'll round off 5.7, 5.85. What would I get? I would get 6 itself. Yes, so can I write limit? Okay, limit x tending to 2, f of x is equal to 6. Yes, there is another concept in limits that you should know. It is called as left hand limit and right hand limit. Let me write that down. Left hand limit and right hand limit. Okay. So what is this left hand and right hand limits? So what was our limit? What did we take as x approaching 2, right? So all the values that are approaching from the right side is called as the right hand limit. And all the values or the points approaching from the left side is called as left hand limit. So in this limits, if left hand limit and right hand limits are equal, only then we can say that the limit exists. So are those equal in the example that we took here? Yes, right? Left hand limit was 6 and right hand limit was also 6. Let me take another example now. Suppose f of x is equal to 1 if x is less than or equal to 0 and 2 if x is greater than or equal to 0. Now, what would our left hand limit be? Our left hand limit would be, yes, that is limit x tending to 0 minus, yes, f of x. What is this now? What is the value of this? Isn't it 1? If we had x over here, we could have substituted in the place of x as 0. But okay, so but here there is no x. It is free of the term x. So we just wrote the value, that is 1. Okay, so now for the right hand limit x tending to 0 plus f of x is 2. Are these both equal? No, right? They are not equal. So does the limit exist? No. So I can write, since LHL is not equal to RHL, limit does not exist. Okay. If you had no party to attend to, you wouldn't have a limit, right? Yes, this means the same. Moving on, suppose g of x is equal to mod x. Okay, suppose g of x is equal to mod x. Imagine that this is a function and they are saying x is not equal to 0. Yes. Now let me plot this graph. How would this graph look like? Here is the graph. Yes. You can observe that g of 0 is not defined. Why? They are telling that x is not equal to 0. Yes. So now in this graph, these lines are g of x, right? These are the outputs. This is x. For x is equal to 1, I got 1, right? So I've marked a point over here. Yes, for x is equal to 2, I got 2. Okay, for x is equal to minus 1, again I got 1 because it was mod minus 1, which is equal to positive 1, right? So I can tell this is g of x and this is x, right? So they are saying that this x is not defined. So what is happening as g of x, that is, you see here it would be g of 3, agree? This is x is equal to 3. This is g of 2, g of 1. So what happens as it approaches to g of 0? We are getting 0 itself. So can I write limit x tending to 0, g of x is equal to 0? Yes. If you still do not understand, write a table like this. You would get 0 itself. Yes. Moving on, let me take a problem. Okay. Before that, let us study something about algebra on limits. Okay. What is this algebra on limits? So imagine I have, or let's say I have f of x and g of x whose limit exists. What do you mean by the limit exists? Left hand limit is equal to the right hand limit. Okay. So yes, if f of x and g of x, for f of x and g of x, if limit exists, then I can write first one as f of x can be added and subtracted. For a limit x tending to a, f of x plus or minus g of x would be equal to limit x tending to a, f of x plus or minus limit x tending to a, g of x. Okay. Second one, limit x tending to a, f of x into g of x would be equal to limit x tending to a, f of x into limit x tending to a, g of x. Okay. The third one is division. Yes, x tends to a, f of x divided by g of x. This is equal to limit x tending to a, f of x divided by limit x tending to a, g of x. Okay, this is algebra on limits. Yes, let me take some problems now. Yes, limit x tending to a, let me take it as x square. Okay, can I write this as limit x tending to a, x into limit x tending to a, x? Yes. So what is this? Can I write this as a into a? Yes. So what would this be? A square. Yes. We wrote this by the algebra on limits, right? And if you ask me, how did you get limit x tending to ax? How can you substitute it as a? You see, here as x tending to 0, g of x, what was g of x? Mod x, right? In the place of x, if you substitute 0, you would get 0, right? Not only like with, okay, not only like directly substituting it, we proved it using this graph, right? Or even over here, see, you substitute x as 2, you would get 6. And we even saw what happens as we took like the nearest values to 2. We got all the values approximately 6 itself. So now directly I can write limit x tending to 2, f of x, substitute the value of 2 in place of x and write it as 6. Yes. So now moving on, let me take another problem now. Limit, okay. So limit, yes, x tending to a, x power n. What would this be? X is tending to a, so in place of x you write a. We have x over here, so you write a. Yes, that's it. So next one, suppose f of x is equal to a naught plus ax plus a1x plus a2x square. Now, what would be the limit if x is tending to a? Okay, let me write it. Limit x tending to a naught plus a1x plus a2x square. Again, from the algebra on limits, can I write limit x tending to a naught plus limit x tending to a1x plus limit x tending to a2x square, right? So now, do you have x over here? No, so just write it as a naught itself. Do I have an x over here? Yes, replace this x with a, so I would get a into a1. Yes, do I have x over here? Yes, right? Replace it. You would get a square into a2. Okay. So can I write this as f of a? Yes, this was f of x. In place of x, I replaced it with a. So I have written it as f of a. So now, next, let me take f of x is equal to, yes, f of x is equal to some function g of x divided by h of x. Here, x tends to a. So now I can write it as, okay, so f of x is equal to limit x tending to a g of x divided by h of x. Okay, you can even apply limit over here, x tending to a. Okay, so what can I write this as? Replace x with a. Yes, but how would you solve the RHS? From the algebra on limits, can I write the, yes, divided by limit x tending to a h of x. Okay, so now in the place of x, replace it with the limit, that is a. Yes, so finally what did you get? F of a is equal to, okay, so f of a is equal to g of a divided by h of a, right? Now, let me take another problem, that is find the limit. Okay, find the limit. Yes, find the limit. So the first question is limit x tending to 1, okay, minus 1, and they are telling 1 plus x square, so on up to x to the power 10. So you have 10 terms over here. Okay, so the power raises till x to the power 10. Now if you substitute minus 1 to x, you would get minus 1. If you substitute minus 1 to x cube, you would get minus 1 the whole cube, which is equal to again minus 1. Yes, so basically if the power is an odd number, you would get the output as minus 1. Yes, what would you get for x square? I would get minus 1 the whole square, which is equal to 1, right? So there are 5 odd terms. Okay, so there are 5 terms with odd power, right? and there are 5 terms with even power. Agree? So what are the terms with odd power? X, x cube, x to the power of 5, x to the power of 9, right? How about even power? X square, x power 4, x power 6, x power 8 and x power 10. Agree? So can I write this as 1? Because the 5 even and 5 odd powers get cancelled. Okay, so now the second question is limit x tending to 2, yes, x square minus 4 divided by x cube minus 4x square plus 4x. Okay, so now what do I do? Let me replace x with 2, right? So yes, I would get 4 minus 4, is it 0? Yes, 4 cube, 4 16, 16 fours are 64 minus again 64 plus 16. So is this 0 divided by 16? Yes. So what would you get? You would get 0 itself, right? Okay, let me solve this again. Okay. So the limit tends to 2, right? So in the place of x, I replace it with 2. So I would get 4 minus 4 divided by 2 cube, right? 2 cube, that is 8, minus 4 into 4, 16 plus 8. So I would get 8 plus 8, 16. 16 and 16 would get cancelled. In the numerator, again I would get 0. Yes. So in mathematics, 0 by 0 form is called as indeterminate form. Okay. It is the indeterminate form which is not defined yet. Indeterminate form. So whenever you arrive at this indeterminate form, you would have to try changing the function. Yes, this is not the answer that you should get. Okay, because this is not defined, right? So how do you change this function? Let me take, you see the numerator is in the form of a square minus b square, right? Let me write it in the form of a plus b into a minus b. Yes, so can I write it as x plus 2 into x minus 2 divided by, yes, let me take x common. I would get x square minus 2x plus 2, sorry, x square minus 4x plus 4. Can I directly write it as x minus 2 the whole square? Okay. Yes, I'll write it as x minus 2 the whole square. So one of these terms gets cancelled, right? What happens if I substitute the value of x as 2 now? I would get, okay, let me write that down. Yes, I'm substituting limit x tends to 2 here. Okay, so I would get 4 divided by 0. Yes, because 2 minus 2 is 0. What would this be? Anything divided by 0 is not defined, is it? Okay. Yes, so 4 divided by 0, it is infinity. Okay. So yes, 0 by 0 is an indeterminate form. It is not defined. That is why we just simplified. We tried simplifying it and we got 4 divided by 0, which is equal to infinity. Okay, so what did we study in this class? We studied something about limits. What is a limit? So as x tending to 0, yes. So any point for a function, if we take any point, so we observe what is happening to that function as that point is approaching the function. Yes. What was left hand limit? The point approaching that. Okay. So the points approaching the limit point. Okay. So all the values approaching to the limit point from the left side is called as the left hand limit. Okay. And all the values from the right side, that is approaching the given limit value, is called as right hand limit. So only when this left hand limit and right hand limit are same or equal, we can say that the limit exists. Okay. So for example, we took a problem in which left hand and right hand limits were in same. So we said that limit does not exist. Okay. So yes, and then algebra on limits, which said that we can add, subtract, multiply and divide limits. Okay. And then we solve some problems. Okay. So yes, that is it for today. Thank you.